Okay, we're looking at two new rules today. Powers of indices and power of zero. Okay, if we've seen things like a to the power of 4, but if we want something like a to the power of 4 cubed, that just means a to the 4 times a to the 4 times a to the 4, where it's done, sorry, that's meant to be an a, where it's done 3 times. Does that make sense? Just like 5 cubed is 5 times 5 times 5, a to the power of 4 cubed is the a to the power of 4 and it's cubed, so it's a to the power of 4 times a to the power of 4 times a to the power of 4. Now, using the rules that we learnt last lesson, that if you're multiplying terms and bases are the same, that you just add the indices, it would be a to the power of 4 plus 4 plus 4, which is 12, a to the 12. Now, that obviously takes a long time. The other thing, a quicker method, is just notice what's 4 times 3? 12. So if we did a few more examples like that, we would get the same thing. If we look at this one here, x cubed to the power of 5, that would be x cubed times x cubed times x cubed times x cubed times x cubed. The 3 would be added up 5 times, which is 15. Isn't it just quicker to say 3 times 5 is 15? So when you've got brackets to a power, you just multiply the indexes, the indices. So when an expression in brackets is raised to a power, multiply the two indices. And the rule's down here. A to the power of m, if that's all then to the power of n, it's just a to the power of m times n. So with the first one, x cubed to the power of 5, we just multiplied the 3 and the 5. But with the next one, you've got to be very careful, girls. This is 3 to the power of 2. There is a times symbol between the 3 and the a squared. So that's 3 to the power of 2 times a to the power of 4 to the power of 2. Do you get that? Girls, they're both to the power of 2. Everything in the brackets is to the power of 2. It is not 3a to the power of 8. It's 9a to the power of 8. A lot of people make the mistake where they'll just put 3a to the power of 8. They'll remember to multiply these, but girls, this is just 3 squared. That's just done normally with numbers. 3 squared is 9, and with the a, what do I put? 9a to the power of? What happens to the 4 and the 8? So girls, you've got to separate out what's in the bracket. So with this one, it's 2 cubed times, why am I putting a times symbol? Because there are multiplication symbols between all of these. Times x4 cubed times y squared cubed. Are you okay with that, girls? Everything is cubed. The 2 is cubed. What's 2 cubed? It's 2 times 2 times 2, which is 8. What's x4? X to the power of 4 cubed. X to the 12. Y squared cubed, y to the 6. Good. Now, with the next one, girls, what should I do first? Yeah, it is as a fraction. I'm going to open those brackets first. So I'm going to keep my 4a cubed b times, can we do this in one step? What's 2 cubed? I'm going to cube each of these. What's 2 cubed? Or I can just do it all separately. Do you want me to do it all separately? 2 cubed times a squared what? Cubed times b cubed over 8a to the power of 5b squared. Okay, let's work out what we've got. We probably should have written a6 here. That would have been better. Save us a line. All right, I'm just changing that a squared to the power of 3 to an a6 just to save a line of writing. So, girls, we can simplify the numerator. Look at the what's 2 cubed, girls? 2 cubed. 8. 8 times 4. I'm doing the numbers first. What's 8 times 4? Actually, girls, if that's 8, instead of doing 8 times 4, I can just see how there are multiplication symbols on the numerator? And they're all multiplication symbols between these on the denominator. See this 8, what will it cancel with? With the 8 in the denominator. No need to do 8 times 4 is 32 and 32 divided by 8. If you've got multiplication symbols between everything on the numerator and the denominator of your fractions, you can just cancel out to your heart's content. Now, I'll tell you when you can't do it. If there was a plus or minus anywhere on that numerator or denominator, forget it. You're not allowed to do it at all. So everything must be multiplication symbols. And if they are, you're allowed to cancel between numerator and denominator. So 2 cubed is 8 over 8, that cancels. So looking at the numbers on the numerator, I've got 4. Now let's do the a's. A cubed times a to the power of 6 is a to the power of? No. That's a cubed times a6. Yeah, a9, because you add a9. And then we've got b times b cubed is b to the power of 4 over a to the power of 5, b squared. Now what do we get? 4's right. A9, that's an A9. It looks like an AA. A9 divided by a to the power of 5. What's that? A to the power of 4 on the top. B to the power of 4 over b squared is b 2. B squared on top. No, it's not 4 divided by 9. A9 divided by A5, bases are the same, and you're dividing, you subtract the indices. We did it last lesson. It's still there. That 4's still there. This 8 and this 8 cancelled. If you want, you can go 8 times 4 is 32, put 32 over 8, and you'll still get 4. It's just that as questions get more complicated, you're best off trying to simplify your numbers, if you can. All right? All right, let's try some more. All right, try these yourselves. I'll just pause. So remember, you're going to have to expand the brackets first for these down here when you get to them. I'll give you a minute. These, we've got a power raised to another power. What happens with the 4 and the 5 and the 4? You multiply. 5 times 4 is 20. With this, it's 4 to the power of 3 times n6 to the power of 3. You've just got to say they're both to the power of 3. All of that in the brackets is to the power of 3. With numbers, you do them normally as you would with numbers. 4 cubed, girls, what is it? 64. And then n to the power of? Now the next one, it's 3 squared times a5 squared times b4 squared times c squared. Girls, as you get more confident with them, you won't need to do that step. You may be able to just write the answer straight away. What's 3 squared? 9. Then a, 10, b, 8, c squared. So 9, a to the power of 10, b to the power of 8, c squared. The last one, girls, I'm sure we can expand this. Yeah. Because 4 cubed, 4 is to the power of 3, and n6 is to the power of 3. Isn't the rule that you multiply? Look, x5 to the power of 4, 5 times 4 is 20. 6 times 3 is 18. All right, the last one down here. How do I expand ab cubed? A is to the power of 3, and b, you don't have to put a times symbol if you don't want. A is to the power of 3, b is to the power of 3, times 2, a to the power of 4, b squared, over, girls, do we want to just expand this straight up? The 2 is to the power of 2, what do I get? What's 2 to the power of 2? A to the power of 4 is also to the power of 2, I'll just put that down here. What's that? A4 to the power of 2. A8, and the b is also to the power of 2, which is b to b squared. So that was just that little bit of working out there. The 2 is to the power of 2. A4 is to the power of 2, which is a to the power of 8. B is to the power of 2. Now, girls, you can, if you want, just have a look. I mean, you can simplify the numerator. What have you got with the numbers on the numerator? 2. What about the a's? A, 7, b, 5, over 4a 8b squared. Be careful here, girls. What's 7 take away 8? All right, let's not do it that way because we're doing that in later lessons. I want you to think of a7 as a times a times a times a 7 times, and a to the power of 8 as a times a times a 8 times. Where do you have the extra a? On the top or the bottom? How many extras on the bottom? So we're just left with an a on the bottom. What about the b's? B what? B cubed on top or bottom? Girls, it's really good to think of it when we first learnt the rule. Especially if there's higher powers on the denominator than there is on the numerator. You could put a to the negative 1, but we're not doing that today. And I forgot the 2 and the 4. And what do I get with the 2 and the 4? 1 over 2. Do I need the 1 on the numerator? So I just put the 2 on the denominator. 2 over 4 is a half. I can put the 1, but I don't need the 1 on the numerator. So it's b cubed over 2a. Okay, so girls, okay, listening closely. Girls, what's a cubed divided by, girls, what's 5 divided by 5? 100 divided by 100. Anything divided by itself, just looking over here, what's anything divided by itself? So something over itself is 1. Now looking over here, a cubed divided by a cubed, can't they be written as a cubed divided by a cubed? Yes or no? And doesn't that mean if the bases are the same, subtract the indices, a to the power of 3 minus 3, which is a to the power of 0? Girls, are you watching? Well, if a to the power of 3 over a to the power of 3 equals a to the power of 0, and as I was just saying here with our 5 divided by 5 is 1, anything divided by itself is 1, therefore it must hold that a to the power of 0 is 1. So girls, if you want, get your calculators out and just do 10 to the power of 0, 5 to the power of 0, any number you want to the power of 0, and you will see, I want you to try a couple of numbers to the power of 0. So try a couple of numbers to the power of 0, and I want you to see for yourself that it is 1. Power of 0, you use the y to the x button or the x to the power of y button. Okay, so our rule is any pronumeral or number raised to the power of 0 is equal to 1. So girls, the first question, what is a to the power of 0? 1. Be careful here, girls. This means 4 times x to the power of 0 plus 3. Because, girls, between numerals and pronumerals, there is a multiplication symbol. So it's 4 times what? 1 plus 3, which equals 7. Very good. Girls, all of that 2 to the power of m, all of the 2m, whatever it is to the power of 0. What's the answer? All of that is to the power of 0. What's the answer? 1. No, it's not 2. Well, if you want to break it up, you can. If you want, see girls, it's all to the power of 0. The answer is 1. Or 2, what's 2 to the power of 0 times m to the power of 0? Girls, aren't they both to the power of 0? So what's 2 to the power of 0? Times? Now you don't need to do that. Girls, all of it is to the power of 0. If m is 5, ladies, if m is 5, 2 times 5 is 10, 10 to the power of 0 is 1. If m is 3, girls, the m is a pronumeral which just stands in place for a number. That's what pronumerals are. So all of that is to the power of 0. The answer is 1. You don't need to do what I've just done, but I just did that because some people were doubting that that's what it would be. All of it's to the power of 0. So girls, what about here? We got 4a to the power of 4 divided by, good, which is 4a to the power of 4. Or if you want to use, no, you can't use index laws. Are you okay with that? And the last one, girls, what happens with the 5? 5 squared times what? 5 squared times x cubed is also squared divided by, can I put a divide line? 15 times x to the 0, which is 1. Yep. So what have we got? We've got, what's 5 squared? Because the 5, everything in the brackets is to the power of 2. No. That means 5 times x cubed squared. There is a times symbol between the 5 and the x cubed. So the 5 is squared and the x cubed is squared. Okay? So no, it's 5 is squared and the x cubed is squared. You've got to look at each thing separately. Look at the numbers separately. Look at the x terms separately. In other questions, look at, A's separately, the B's separately. Okay? So girls, we've got 25 times x to the power of 6 over 15 times 1. So what happens with your 25 and 15? What number goes into both 25 and 15? 5. 5 goes into 5 times. 5 goes into 15 3 times. You're simplifying the 25 over 15. All good? Okay, your turn. Do the other side. So I want you now doing this side of the sheet, please. I'll give you a few minutes. To the power of 0. This is 6 times x to the 0 plus. Girls, plus what's this bit? All of that to the power of 0 is what? Plus 1, which is 6 times 1. Whoops. Plus 1 is 7. Wait. Oh, wait. Shh. Girls. 6 times x to the power of 0 plus all of that to the power of 0 is 1. So it's 6 times 1 plus 1 is 6 plus 1 is 7. The next one is 5. What symbol is between the 5 and the bracket? It's a times. 5 times what? All of that is just 1. You don't have to work it out. It's all to the power of 0. Divided by 5 times x to the power of 0 is 1. So girls, it's 5 divided by 5, which is, it's 5 divided by 5, which is 1. The next one. Go. 3 to the power of 2 is what? No, it's 3 squared is 9 times m cubed squared is what? M times n squared times, what's m to the 0? So it's 9m to the power of 6n squared. So girls, 3 squared, m cubed squared, n squared. The last one, that's all to the power of 0. Don't bother working it out. What's it equal to? 1 times 5x squared y to the power of 4 over 5xy. What cancels, girls? The 5's cancel with, and you put 1's in their place. X squared over x is y to the power of 4 divided by y. Girls, often with those, when they're in fraction form, I don't use the index laws. I just go y times y times y times y. I know that's in my head, divided by y. One of the y's cancels with one of the top y's. Get the idea? Okay? All right. Now what you're going to do, girls, is come back to this booklet. This booklet here. You know that booklet you've got? Yep. And just continue with that booklet. I think we're on about the 4th page or something. Do you need me to just put, actually we need to go back to last lesson and just check some of the answers. I was rushed at the end. The answers from this last sheet that you did last lesson, k to the power of 8, y to the power of, we got 2 plus 9, 11, and 7, 18. Keep going over here. We've got the 7 is just for the numbers, and then we get x to the power of 7. 9 times 10 is 90 times h to the power of 5. h1 times h to the power of 4. This one over here, you would have got what? 2 times 4, doing numbers first. 8. a to the power of what? We've got 3, 1, and 6. 10. And we've got b to the power of 4 and 5. 9. Okay? All right. The division ones, just going over those. x to the power of 8 divided by x to the power of 4. Subtract the indices. Bases are the same. X to the power of 4. The next one. K to the power of 5 divided by k to the power of 1 is k to the power of 4. This one. What do you do with all these? You go 10 minus 5 minus 2. 3. We keep going. 7 divided by 1 is 7. X to the x cubed. The next one, numbers first. 18 over 6 is 3. H to the power of 3. And I think we've done the other one in class. Bases are both 5. That's 5 to the power of x divided by 5 to the power of 1. Bases are the same. You just do subtract the indices x minus 1. Same idea over here. Bases are all 7. So bases are the same. When you're multiplying on the numerator here, we add the indices. So we do 5y plus 2y divided by this term down here, 7 to the power of y plus 1. So on the numerator, 7 to the power of 5y plus 2y is 7y divided by 7 to the power of y plus 1. Now, bases are the same. They're both 7. So we just subtract the indices. So we go 7, big 7, to the power of 7y, take away brackets. You have to put the brackets because you're taking away all of the y plus 1. Do you get that? It's 7y minus whatever that is. So 7y take away bracket, y plus 1. Now, this is 7y minus y. Let me just write it out. I'll do an extra row here. So we get, I'll just do an extra row. The answer's right. 7y, what do I write now? Take away y. What do I do now? Minus plus 1, minus 1. Do you see that? It's minus take away y, take away 1, which is 7 to the power of 6y. 7y minus y is 6y minus 1. Back at this one here, task 3e, where we multiplied the numerals, we got 48, we got p to the power of 6 over p to the power of 6. I mean, you can think the same thing over itself is 1, or all the p's up here cancel with all the p's down there, or 6 minus 6 is 0, and we know that that's now 1. Do you know what I mean? So, but I would have thought of that as p times p times p times p 6 times over the 6 of them down the bottom, and they all cancel out. Okay, girls, we're going to the other side of the page. Okay, girls. Right, you've already looked at powers of 0, but it just says here, says here to follow the powers of 2. 2 to the power of 5 is 32, 2 to the power of 4 is 16, 2 to the power of 3 is 8. What do you think they're doing as we come down here? We're dividing by 2. We're dividing by 2. 32 divided by 2 is 16. 16 divided by 2 is 8. It's 1 less power of 2. 8 divided by 2 is 4. What's 2 to the power of 1? 2. We're dividing by 2. 4 divided by 2 is 2. What's 2 divided by 2? So that's another way that you can work out what 2 to the power of 0 is, or anything to the power of 0 is. We did it a different way. Okay? So 2 to the power of 0 is 1. On this sheet here as well, girls, yeah, we know this is 3 squared. What's 3 cubed? 2 what? 243. 3 to the power of 1 is 3. Again, just looking at these, look at the pattern. Dividing by 3, dividing by 3. Keep dividing by 3. Powers are going down by 1. This is 3 to the 0. So 3 to the 0 is also 1. But we've already investigated that rule earlier, this lesson. This is actually how I did it on the sheet. So y cubed divided by y cubed, we've already done this, okay, is y to the 0. You know, when the bases are the same, subtract the indices. We did this earlier, but when you divide a number by itself, the answer is always 1. So, for example, therefore, y cubed divided by y cubed is 1. So, just down here, we did this before. y cubed divided by y cubed is y to the 0, and y cubed divided by y cubed is 1, therefore y to the power of 0 is 1. It's just showing in a couple of different ways why y to the power of 0 is 1. Okay? So basically, what can we conclude? That anything, you can just put that any number or pronumeral to the power of 0 is 1. We've already done this. So any number or pronumeral to the power of 0 equals 1. Any number or pronumeral to the power of 0 equals 1. Okay, then you can turn over the page once you're done and do some practice. Lots of different stuff, all the 4 rules. Now, I'm going to write them up the top of the page. Base multiplying, dividing, powers of powers, and to the power of 0. So you've got 4 rules. Okay, I'm turning. Okay, so let's get these. All right, these are 0 power ones. We've already done some, but you can practice some more. And then we've got powers of powers, and then we've got mixed ones. So why don't you have a go at that sheet? I'll give you 5 minutes. We'll then go through it and just keep working through the booklet. 5 times x to the 0, which is 5 times 1, which is 5. All of that's to the power of 0, which is 1. This will be 5 plus 1, which is 6. This will be 1 minus, be very careful. Is it all to the power of 0? No. Only it's 5. 1 minus 5 times k to the 0. 1 minus 5 times 1. What's 1 minus 5? Negative 4. 7 divided by 1, which is 7. Or, if you want to use your index laws, but I wouldn't, bases are the same. 1 minus 0 is 7 to the 1. The next one, 18 divided by 1. Okay, next section. All good? Keep going. Right. Y to the 18. B to the power of 10. Girls, is the 3 to the power of 8 or not? No, it's not. The 3 is not in the brackets. It is not to the power of 8. X to the 16. Girls, I hope you're checking your answers. Is the negative 2 to the power? No, it's outside. Q to the power of 18. Negative 2. Right, be careful. What do? Do the inside brackets first, always. W to the 15 is then squared. What do you get? W to the power of 30. The next one is just 3 to the power of 12, which is whatever. We don't have to work it out. Okay, all good? Keep going. Multiply 6 times y4 is y to the 10. Next one. What happens? A times 18 divided by a to the is a cubed. Great. Girls, be careful. Girls, you know what? Maybe just multiply the first 2 terms first. What's k to the 0? So girls, this is just 5 times 1 times k to the 6 divided by k to the 4. What's 5 times 1? Times k to the 6. 5k to the 6. I'm going to go over k to the 4. Okay? Look, girls, you could just go 6 minus 4 is 2, 5k squared. But, you know, you're supposed to multiply the first 2 and then get the answer and then divide by that. So it's 5k squared. The next one, over. Girls, I would definitely be writing the first bits as a fraction. 3p p to the power of 7 divided by 12p squared. You must, when you've got BODMAS, girls, division and multiplication in the same number sentence, you must do it in order. You can add numbers in any order, you can multiply in any order, but once there's subtraction and division, division and mixed with multiplication and other things, if it's just division and multiplication, it has to be done in order. So whatever that answer is, you're going to times it by 4p0. Now, what do you get here, girls? What's 3 over 12 as a fraction? 1 over 4. I'm not going to put the 1. And we get the p5 on the numerator over 4 times, so I've got p5 over 4 times, what's 4 times p0? 4. 4 times 1, which is just 4. What happens with the 4s, girls? I've got a 4 on the numerator and the 4 on the denominator. Yeah, they cancel. You get 1. So it's 4p5 over 4, which is just p to the power of 5. It's like a quarter. That's like 1/4 times 4 is 1. They cancel. Why? Because there's multiplication symbols between everything. You're allowed to do that. Okay, coming over to the left, or can I do this one first? I'll do this one. 6x to the power of 5 times, what do we get here? 1 over 3x squared. May as well just ignore that 1. What's 6 over 3? 2. Where's the x cubed? On the top. And the last one over here, what happens? What do we get here? H to the power of 6 over h cubed times h squared. What's h to the power of 6 over h cubed? H cubed. So you do that first, get an answer, then times it by h squared. 5. Yeah. Try not to get the rules mixed up. So once you've been doing those, a lot of people then mess these up or they mess the other ones up. Bases are the same, add the indices. Okay, good. Let's go to the other side. Can I turn? That's okay, we keep going. Right, girls, I'm not going to bother with this page. Can you do this one for homework? Do that one for homework. And let's look at the last one very quickly. I'm sure you'll be fine. Actually, come on. Let's do some, can I just start from E? Shh. All right, hurry up. Actually, I'll just start from A. Are we ready? What do you think, girls? First one. They're both to the power of 8. What do you get? B to the power of 8, C to the power of 8. Next one. 10 is to the power of 5. X is to the power of 5. Y is to the power of 5. Okay, girls, everything here is to the power of 4. So the m squared is to the power of 4, and so is the n. What do you get? M to the 8 times n to the power of 4. What about this one? What do we get? X to the power of times y to the power of 9 divided by, I like to do my divides as fractions, x to the power of 5. What do you get? X to the power of 4, y to the power of 9. All good? Now we've got fractional ones because I wanted to get to these because I didn't get a chance. We've only got a minute left. Can I move? Okay, girls. Basically the power of 4, when we were multiplying each thing's to the power of 4, same here, each thing's to the power of 4, it's m7 to the power of 4 over 2 to the power of 4. Just because it's a fraction, still everything's to the power of 4. The numerator's to the power of 4 and so is the denominator. So we get m to the power of 7 times 4 is 28 over 16. 2 to the power of 4. Right, next one, the m is squared. And all of the 7n is also squared. So what do you get? M squared over, what's 7 squared? I can just separate it. 7 squared times n squared. What do you get? M squared over 49. Are we good? N squared. So girls, just each thing is to the power. Like multiplying, but this time we're dividing. All right, we keep going. Good. Keep going. 3 is to the power of 4, and so is k. 3 to the power of 4 is 81. All right, last one. The negative 4 is cubed. So is the 3, and so is the p squared. I hope you're comfortable with this multiplication symbol, because that's 3 times p squared. So that's negative 64. A negative times a negative times a negative is a negative. 3 cubed is 27. So girls, you should always work out these values, unless it's something like really big, over p to the what? 6? Okay, girls. What I'll do, I'll email you the homework. I have to go.